Hey there, my name is Brad Corlett, and thank you for joining A Little Bit of Everything. This is my show where I talk about a little bit of everything. And so today what we're going to be talking about is a new project that I am building, a new open source project and protocol called Browser 2.0 right now. That's the tentative name. So Browser 2.0 is an attempt to make a better browser than the one that we have. This is not designed to make another browser that is compatible with the existing browser, meaning HTML, CSS, JavaScript. This is an idea. Can we scrap the browser, delete everything, and start over from the ground up with a better system? And why do I want to do that? Well, I hate the web browser as both a developer and a user. I think as a developer, having three different languages, HTML, CSS, and JavaScript, and then also sometimes plus JavaScript X, TypeScript, and like a billion other different variants of CSS, HTML, and JavaScript can be a bit cumbersome and convoluted. But also as a user of the web browser, I don't really like the web browser either, because the web browser, it's the year 2025, and I regularly have applications that take anywhere from 5 to 15 seconds to load, even applications from companies that I know have a big budget for their engineering department. When I was a kid, I grew up with a 56K modem that ran at 14.4 because we were so far away from the actual phone company that they had to slow down the baud rate. And so web pages in that era took a really long time to load because, well, that was really all that you had to work with. But now it's many years later, and I have a fiber connection, 500 megabits up and down, and it still regularly takes an incredible amount of time to load a web page. Why? I don't really know. My speculation is that it's bad code and that they're just downloading a billion different node modules. And so I think that the way that we're designing the browser, I think the browser is over-engineered, as well as the way that we actually design applications. And so what I'm trying to do is figure out how can we make a browsing protocol that is feature compatible, or at least does all of the things that we need it to do without all of the other stuff that we don't want. There's too many ask cookies and then pop-ups about my email, and then you say, do I want 30% off? And I try to click no, but then the picture loads and the button moves, and then I click the other button and it goes to a different link, and then I'm on a different page, and then I gotta wait 10 more seconds for that one to load, and then start the whole process over again. So how can we make a better browser? I want the browser to be lightweight. I think the browser should be embeddable in everything from your Office document suite to professional software like image editors and video editors. It should be embeddable in video games and also even low power embedded devices, think Arduinos and microcontrollers and stuff like that. It's the year 2025 and we should have websites that just work. But not only just work reliably, just work quickly. And so the way that I want to do that is right now I'm proposing a new a new protocol that would be entirely in JSON, and you use one language for the styling, which is CSS, the layout, HTML, as well as the scripting, which currently is JavaScript, TypeScript, JSX, or a billion other JavaScript-like programming languages. But this scripting language, in order to actually be reliable and have speed, is going to be a functional programming language. We're not going to have side effects, we're not going to have loops, and we're just going to simplify the application or simplify the scripting so that the applications just work. And so I'll get into that more later about how having a functional scripting language would increase reliability and speed. But for now, let's get into a little bit of a demo first. So right now I have two example clients that I'm going to show you. The first one is actually just a very simple one written in Python using Python's built-in tkinter application. And so again, this is to demo that I really think this can be done in a very lightweight manner. You can take a look if you're interested at the source code. Here is the repository. It's part of another project. And I do want to warn you that this is going to be just a touch underwhelming because it is still a proof of concept. But here, ready, 2, 1, go. Whoa, look at that. Hello world. I am a sample page. All right. So yeah, just a bit underwhelming there. But this is what we got. So I will show the actual JSON for this in a bit. So we also have another one here that we can show you that's a bit more complicated. We have a few different buttons and a few different links and stuff like that. Okay, as you can see here, this shows off a little bit of the scripting here. So we can type our name in here. I can't actually type is what you're witnessing, but anyway, so you can see that we're typing into this form, and then we're actually using that to modify our layout down here. We also have this button here, which is giving us a random number here, so that's showing off our scripting. And then also you can see we have a timestamp right here, and every time we re-render, that timestamp gets updated. And so that shows off a little bit of the scripting. So we have different headings and things like this. We have links here. These links go to they're backward compatible with the existing web browser. But eventually I'm going to be adding more like actual links from one browser 2.0 page to another browser 2.0 page. But we're still early in this. So this is just a pretty simple demo. Now let me show you the same thing but in a different client, which is a bit more interesting than this one here. Okay, so let's take a look here at client number 2. So this one grew out of a project, a music player and visualizer project that I have started. You can see the link here for the repository if you're interested in the source code. And so this one is built on top of Blender. If you're familiar with Blender, it's a 3D open source program. It's one of my favorite, if not my favorite, open source piece of software. And so they have a concept called an application template, which allows you to build your own customized user interface on top of the guts of their program. And so let me just show you real quick a bit about how the music visualizer works, and then we'll get into the browser. So it's a sound reactive visualizer. You can resynchronize this basically just by clicking on any of the other songs that you see in that sidebar. We can resynchronize this. And so it's a 3D animation driven by the sound waves of whatever we're playing here so that it stays in sync. And so you can see that we have a few other different visualizer choices here. This is a 4-band equalizer with a peak meter at the top there. And so then let's take a look here at what happens when we load one of our pages. So we can pop our hello world up there. And so you can see that the visualizer moved down here to the right when we did that, and that's so that we don't have it blocking our text. Here's the other document that I showed earlier. And so we have this button which works. You can see the timestamp up here works. I have not implemented an actual form input. I just have a placeholder here for that, but I've done enough proof of concept where that will eventually work. There's also a credits page here. So the music that I'm using in this project comes from a Creative Commons source called the Free Music Archive. So I'm giving credit here to where the music came from. But then also with the visualizers, I made some of those based on a tutorial that I found on YouTube. And so you can find the link to that tutorial here. And then of course, there's a few different open source pieces of software that I have credits for as well. And so the whole idea that I'm trying to demonstrate with this is that there is a better way to make a browser. You know, we can have all of the benefits of the existing browser, but I think better. So making this animation in Blender is about 100 billion% better than doing it in JavaScript. And you don't need to write any source code. You use a user interface designed for artists. And so what we can do here is just kind of simplify the layout, simplify the style of the actual web page, and then all of the fancy stuff is up to the application. So again, we can embed this browser in 3D programs, in video games. We can embed it wherever you need it to be, in your Office document, in your spreadsheet, in whatever it can be. And so I think that we can end up creating a lot of really unique experiences this way. So now I want to go over the JSON file that we're using to render this. So you can see it right over here. So we have this params block, we have a state block, ops, and output. So let's go through these one by one. So params, this would be kind of similar to like a request body or URL parameters on the existing web page. And so this one right here, if you change this to true, it will change the way that this renders. So if it's our first time, it'll say welcome in because you're a new user. If it is not your first time on this page, it says welcome back. And so that's our parameters block. Let's take a look at our state real quick. Or actually, you know what, let's look at output first, and then we'll come back to that. So this is basically our layout. The output block is basically the layout. So you can see we have a heading here, level 1, and it's our example document. So that's our heading right there. And then we have a block, which in HTML, this would be similar to like a P tag, a paragraph tag. And then you can see we have text right here. Lingo is used for dynamic stuff. This is basically this function here returns, well, it's datetime.now, which if you're familiar with Python, it's grabbing the date time, and so you can see that right there. And so it basically returns effectively a text block. Once this is rendered, every time the page is generated, you dynamically change this output block. So we're of course looking at the original state of it, but once you render it, this will be changed to a text block with the string representation of that date time. And then you can see we put a period after it. We have a BR, a break is what we call it, but it's like a BR in HTML. And so then we can jump down here and we have our input. It's a text input, and we're binding it to the state value called name. So that's up here. We'll get back to that. Or well, let's actually show that right now. So it binds it to name. So you can see we've defined our state. Our name value, it is a string, and the default is an empty string, which is an empty string right now. And so then let's go down to right here. This is where we're actually using that name value. And so you can see if you look at all of this right here, and if now it's been so long since I've done this. So if the call to not equals, that's what this NE. So if our state.name equals empty string, then we're returning state.name, or actually I said that backwards. Well, yeah, if it's not equal to an empty string, then we return the state.name value, else we return unknown person. So you can see right now, because we have not entered anything in this form, it's returning unknown person, but then when I type in my name, we're rendering that. So over here you can see, yeah, it's this part right here. And then the welcome back, that comes from our greeting, our state.greeting value. So we go up here to state, and greeting is a string, the default is empty string, and then this is a calculated state variable. And so we branch, so if parameter first visit, then welcome in. Remember, so the param was up here. So if it's our first visit, then we have welcome in. If it is not, then it's welcome back. And so you can see that's how we're rendering that right here. So then we can also take a look real quick at a few other things. So we also have a switch right here. That is over here. So the day that I am recording this, you can see it is a Friday. And so the switch, we have our expression we call current.weekday. And so that gives us our current weekday as a number. And so then based on, if it's a 0, then we're going to say Monday, blah, blah, blah. I don't need to read all of these. We have a default here. So if I've only listed the weekdays, and then any other value will give us weekend. And so you can see that's a switch. We have a link. The link, this is a regular browser 1.0 legacy browser, as I like to call it. Link. So this will actually open in your web browser. It'll use your system web browser to open that link. But eventually, in the future, we'll have more links from browser 2 pages to browser 2 pages. But we're still early in this proof of concept. And so one other thing we want to look at here is, let's take a look at our randomize button. So we have a button tag which is linked to our operation called randomize number. So text, this is what we show on the button, randomize. And then op is connecting our button to this operation called randomize number. So we open up our operation, we have one randomized number operation defined. And so it takes args. It takes one argument called max, which is an integer value. And so if we look over here, you can see that when we're defining this, we are inputting our max as 100. So if we wanted to reuse this operation in multiple spots, we could change what that maximum number is. We could, of course, add other arguments. If we wanted to add the minimum, we could. But so then we go down to function, and what we do here, we're using the set parameter here. So we're setting state.n. So our state.n is an integer with a default of 0. And so we set that value to the response from random.randomInt. And then the args that we pass to that we're hard coding the minimum to be 0, and then the maximum refers to this right here. So we can just keep running that, and so we will be generating between 0 and 100 every time. So you'll notice that the functions here are similar to, they're basically inspired by and built off of Python. Right now, the only rendering engine in both of these clients is based on Python. However, eventually I do want to be able to create clients in everything. Go, C, whatever language you want, we should be able to create one. And then the scripting language will just simply use the vernacular, the vocabulary of Python, if you will. And so then if you were to write a client in Go, you would need to implement these functions. So you need to implement a datetime.now or a random.randint. So we're just kind of using the batteries included syntax, or not syntax, but batteries included libraries of Python. And so then any client in any language would be able to just implement these. And so in the future, I'm going to be adding a lot more functions, a lot more of those built-in battery included functions from Python. It should also be able to work with your camera, GPS. There should be local storage and different things like that. There will be more styling, and but I don't want there to be too much styling, again, because I think that part of my problem with the web browser is that we're overcomplicating and over-engineering it. There should be styling, but I also think that you should be able, as a user, to turn that styling off, because that gives the user local control over all of the data. And that can be beneficial for a few different things. Let's say you're looking at some data on the web browser and you want to perform your own math on it or whatever. You could easily grab it and pop it into a spreadsheet. Or again, if, like I've been mentioning, you can embed this into different programs. So if you wanted to analyze data that you're looking at more, you can open it in your browser that is attached to your spreadsheet, and then you can kind of take that data and do whatever you want with it. But also it would have a lot of benefits for accessibility for people who are blind, for people who don't have the same ability to control a computer. And so by simplifying the browsing protocol, I think we can actually expand a lot of it. We spend so much of our time in the web development space with all of these high, bars of flashy websites and flashy this and that to make it look cool and marketing, and we got to have, sell it to our customers and blah, blah, blah. But I think that in a way, simple is better. And it can, I think, actually really make the web browser a lot more usable. Eventually, there will also be requests added into this so that you can contact the backend and get additional data and do CRUD operations and different things like that. Right now, it's relatively limited just as a proof of concept, but this is where the protocol is right now. So I want to go over a little bit more about the theory behind it, about why it's a functional language and why I want it to be sort of stripped down and limited. I think a lot of developers, a lot of front-end developers would find the protocol to be quite limited based on its functional nature and the limited styling that I want to apply to it. And that's kind of the point, is to be a bit more limiting, because I don't think that we need so much in the web browser. You shouldn't be able to open so many different video streams and overlay that my phone or computer crashes. And yet I seem to notice that all the time I see web pages freezing. If you need more than one stream of video or audio to be playing at the same time, the web browser is not really the place for that. The web browser should be instant. It should be reliable. It should be fast. It shouldn't be for all of the big flashy things that we have. And so we want to simplify it, get rid of CSS, HTML, JavaScript, and just have one language instead of many different languages in many different dispersed states. And with the typed and functional scripting, the reason for doing it that way is that typing gives you a lot more reliability. That's why a lot of people like TypeScript. But it nonetheless compiles down to a crappier language, JavaScript, that is not typed. And so what I learned when I learned how to write Haskell, which is a purely functional programming language, is that you don't need a lot of the other features that programming languages bring with it. You don't actually need looping, like a for loop, a for each loop, or a while, or a do while. And you can iterate functionally using things like zip and map and reduce and accumulators and stuff like that. And what I learned is that with Haskell, once you get the program written, it kind of just works. There's not really much kind of troubleshooting that you need to do. After it's built, it's pretty much just reliable. And it's hard to explain if you haven't actually used a purely functional language like that. But what I learned is that loops are like intersections when you're driving. This is the analogy I make, where humans can drive straight really well. It's the intersections where we have problems and we get in car accidents. And so with functions, you kind of get rid of that. And so loops are like intersections because there's a lot of different ways you can enter and exit a loop. There's off by one conditions, or there's, you might have breaks, and you might have continue statements, and then nesting your breaks and continues in multiple loops. These are kind of error prone things. And when you iterate functionally using something like a zip or a map, there's not really any way wrong to exit out of that loop. And so the thing is that once you get the thing working, if it's fully typed and you don't have any of those things, there's not really many things that can go wrong with your application. So not to say that the logic will always be perfect. Of course, you can still have bugs, but the logic will at least work. It just might be wrong, but it'll at least work. And so that gives you the ability to make a reliable program that just works. And it works quickly because if you chain together 5 functions, what's going to take so long about it unless you're calculating a really gigantic number? It's all of these other things and these fancy design patterns and these all sorts of abstractions built on top of abstractions built on whatever that adds processing time and memory overhead. And so the whole point is to just get rid of that. The browser should be mostly about information display, and that's kind of about it. Thank you for making it to the end of the video. Once again, my name is Brad Corlett. If you're interested in this project, please follow along. You can see the links to get to the projects. If you're interested in contributing or letting me know what you think, put it in the comments. Thank you.